now let's start with the first question. Let f of x be a quadratic polynomial such that f of minus 2 plus f of 3 is equals to 0 if one of the roots of f of x is equals to 0 is minus 1. So let us assume our quadratic equation is first of all ax square plus bx plus c is equals to 0. Now it has two roots. One of them is alpha and one of them they have given us that it is minus 1. So now we have to find out alpha based on this equation that they've provided us. Now how can we do that? First what we'll do is we'll rewrite our quadratic equation in terms of our roots. So how do we write it down? So how can we write it down? It can be written as x square minus of sum of roots, which is alpha minus 1, x plus product of roots, which makes it minus alpha. So this is our quadratic equation. Now based on this quadratic equation, we'll try to satisfy this equation. So first what do we have? Minus 2. So this would become minus 2 whole square minus of alpha minus 1 into minus 2 minus alpha plus we have f of 3. So this would become 3 square minus alpha minus 1 into 3 minus alpha. This is equals to 0. So now let me simplify this and we will find out the value of alpha. So from here what do we get? This would become 4. This would be plus 2 alpha. This would become minus 2 minus alpha plus 9 minus 3 alpha plus 3 minus alpha is equals to 0. So from here minus alpha and this plus 2 alpha gets cancelled out, and from here what do we get our value of alpha to be? This becomes 14 and minus, so this will become 14 by 3. So this is our value of alpha. Now we found out our second root as well. Now what did we need to find? We needed to find out the sum of roots. So my sum of roots would simply be 14 by 3 minus 1. This makes it 11 by 3. This is our answer. So this is how normal summation of roots question is solved. Let's look at the next one. The number of real roots of this equation. So we need to find out how many real roots are there in this equation. So first of all, since you can see all the equations that have been given to us are inside root under. So first and foremost thing, what are we going to do? We are going to find out the domain of x, so that we at least understand what is the values of x that are going to be possible. So first, as we had studied in our chapter functions as well, first we are going to find out our domain. So for each and every square root, the value inside it needs to be greater than equal to 0. So from here we can say x square minus 4x plus 3 should be greater than equal to 0. So from here what are the factors of x square minus 4x plus 3 that we are getting? The factors are going to be x minus 3, x minus 1 greater than equal to 0. So from here we get x belongs to from minus infinity to plus 3 union up till 1, and from here we have 3 to infinity. So this is our first domain. Let us find out for the second one. We have x square minus 9. This should be also greater than equal to 0. So from here we get x plus 3 into x minus 3 greater than equal to 0. So from here what would we get? Our x belongs from minus infinity to minus 3 union 3 to infinity. This is our second domain. Let us find out for the third one as well. So we have 4x square minus 14x plus 6. This should also be greater than equal to 0. So from here what do we get? We are going to get, if we try to factorize this, what if I take 4 common from here? We would be left with x minus 3, and this would become 2x minus 1 greater than equal to 0. 2, I've taken it out common by 4. So this would become x minus half. So this would become the factors of this equation. So from here what are we getting? 4 can simply be removed. So we get x belongs from minus infinity to half union 3 to infinity. So we've gotten our 3 domains now. Now we know that x value should satisfy all these 3 domains. So basically what are we going to do to find out our main domain? Our main domain would be 1 intersection 2 intersection 3. So from here what do we get? Our main domain would become from minus infinity to minus 3 union 3 to infinity. So that means first of all we understand that our values of x that we find out after solving this entire quadratic equation should be in this range or should be in this domain. If it is not in this domain, then of course our value that we found out is incorrect. It wouldn't be a real root, right? So now what we'll do is simply factorize this and then we'll square it up. So for the first square, what can we write it down? It can be x minus 3 x minus 1 plus this would be root under x plus 3 into x minus 3. This is equals to root under, here we have 4 times of x minus 3 x minus half. So in all these 3 equations what you can see is x minus 3 root under is common, so I'll take that as common. So it would become x minus 3 into root x minus 1 plus root under x plus 3. This is equals to root x minus 3. I've taken it as common, so this would become root under 4 times of x minus half. So now I can cancel out x minus 3 provided I have to consider that x can be equal to 3. So this is the one real root that I'm getting. If x is equals to 3, that means both sides would become 0. That means my equation would be satisfied, right? So this is the first solution that I've got. Now that I've cancelled it out, what I'll do is I'll square both the sides and check what are the values that I'm getting. So once I square it, what do I get? X minus 1 plus x plus 3 plus 2 times of root under x minus 1 into x plus 3. This value is equals to 4 times of, or let me just simply multiply it. So this becomes 4x minus 2. Now if we multiply it further, we get 2 root under x minus 1 x plus 3. Now simplifying this equation, what do we get? We would have 2x here and this would make it 2. That 2 would come to this side, it would become, sorry, here we would have a plus 2 taken this side, it would become minus. So we would have a 4 here. So from here again 2 can be taken common and cancelled out. So what are we left with? This would become x minus 1 into x plus 3 root under this is x minus 2. Now if I square both sides again, I would get x square minus x plus 3x minus 3. This is equals to x square plus 4 minus 4x. So from here x square can get cancelled out, and what is the value of x that we are left out with? This would become 2x, this would become 6x equals to 7. From here we get x is equals to 7 by 6. So this is another value that can satisfy this equation. However, if we try to check in our domain, 3 lies in our domain, 3 is included in our domain, so this is one of our real solutions. However, this value does not lie in our domain, lie in our domain. Thus we can say that there is only one possible solution, and that is 3. So the number of real roots of this equation is 1. This is our answer, and that root which we are talking about is 3. Let's move on to next question. Let greatest integer function x denote the greatest integer less than or equal to x. Then the values of x belongs to R satisfying the equation. Here there's a bit of printing mistake. Just correct this entire equation. This equation wouldn't be in this format. This equation is basically e to the power x whole square plus, here we have e to the power x plus 1 minus 3 is equals to 0. So it is not ex, it is e to the power x. So we have to find out at what values our x is lying basically. So first of all, what we'll do is, since we know any integer value which is inside greatest integer function can be taken outside. So let us simply take it outside. We get e to the power x whole square plus, this would become e to the power x plus 1 minus 3 is equals to 0. Now I'll simply write this down as minus 2. Now what I'll do is I'll assume e to the power x, this bracketed function, this is equals to t. So what would I be left out with? This would become t square plus t minus 2 is equals to 0. So from here I can see what are my values that I can get, or my factors. This becomes t plus 2 and this would become t minus 1. This is equals to 0. So either t is equals to minus 2 or t is equals to 1. So I'll write it down here. So if my t is equals to minus 2, that means what I'm saying, e to the power x bracketed x, this is equals to minus 2. Now is this ever possible? No. E to the power x can never be negative. If it is never negative, that means its greatest integer function also can never be negative. So this solution is cancelled out. Next we have t is equals to 1. Now I can say e to the power x. If anything inside greatest integer function is equals to 1, that means that value would be ranging from 1 to 2, where 2 is not included and 1 is included. So from here I can say e to the power x would be less than 2 and greater than equal to 1. Then only we could have gotten this value to be 1, right? If this is the case, now what I'll do is I'll take ln all these sides. So I'll have ln 1 less than equal to ln e to the power x. If we have ln e to the power x, it can simply be written as x less than ln 2. And ln 1 is what? It is nothing but 0. So we have our x ranging from 0 to ln 2. And this is our answer. We had to find out our range of x, right? So we've gotten it from 0 to ln 2. And let's see which is the value that satisfies it. So it is going to be this one. Here there is again a printing mistake, I must say, sorry for that. This is going to be an open bracket here. Of course, we cannot include ln 2 in our answer, because if we have 2, the greatest integer function would simply become 2 and it wouldn't be 1, right? So ln 2 cannot be included. So we have our answer as this. So you must understand this. Sometimes the equations might be given to you in a very complicated format. Simply what you can do is substitute it as some another variable, try to solve the quadratic equation and then get the answer. Let's look at this question. If alpha and beta are the distinct roots of the equation this, then the value of alpha to the power 96, alpha to the power 12 is. So first of all, in such type of questions, what is your initial task? Your initial task is to check whether this 12 and 96 are divisible or not. Yes, you can see that these two are divisible. 12 times 8 would give us 96, right? So first of all, that means if we are able to find out the value of alpha to the power 12, we would be able to find out alpha to the power 96 also. So how can I find out alpha to the power 12 when I have been given this equation? What I'll do is I'll keep x square and the constant terms together and the other part to the other side, because I have 3 to the power 1 by 4 here. Of course, the value is very small, so it can get complicated in these situations. So we'll do x square plus root 3. I'll keep it to this side and I'll take this to the other side. This would become minus of root under 3 x. I hope you all have understood why I have written root under 3. Now what I'll do is I'll square both these sides. If I square both these sides, what am I going to get? This would become x to the power 4 plus 3 plus 2 root 3 x square, and this would become root 3x. Now again I can square this entire equation once again so that I can get this root 3 removed. So if I square it once again, sorry, this would also become x square, right? So now what I can do is I can take this x square this side, and if I take x square this side again, I would be left with again a square term on this side and another term on this side. So again I could square the entire equation. So this would become x to the power 4. Here what I did was I squared both the sides. Plus 3 is left here, and here what are we going to have? Minus of root 3 x square. If I take this here, it would become minus, right? So again I square this entire equation. What do I get? X to the power 8 plus 9 plus 6x to the power 4. This is equals to 3x to the power 4. Now if I look at this entire equation carefully, what do I have? X to the power 8 plus 3x to the power 4 plus 9 is equals to 0. This is the equation that I'm getting, right? So now what I can do is I can put my x to the power 8 as minus of 3x to the power 4 minus 9. Now what I'll do is I'll multiply x to the power 4 on both sides and let's see what I get. What I'll do is I'm multiplying x to the power 4 on both sides so that this x to the power 8 can be converted into x to the power 12. So I'll get x to the power 12 here. I would have 3x to the power 8 here minus 9x to the power 4 here. And if I take minus 3x to the power 4 common from this equation, what am I going to get? Here I would have x to the power 12 is equals to minus 3x to the power 4 taken common. Here I would have x square minus 3. X squared minus 3. Sorry, this would not be x squared, this would become x to the power 4 minus 3. Now what I'll do is I'll check from the previous equation. What was x to the power 4 plus 3? It used to be root under 3 x square. So now I'll try to substitute my previous values in this equation so that ultimately at the end I can get no values on this side. Or simply what I'll do is, now that I've found out my x to the power 8 on one of the sides, what I'll do is I'll replace this x to the power 8 with this value that I've gotten. So this would become minus 3 times of x to the power 8 can be replaced by minus 3 x to the power 4 minus 9. And here I would have minus 9 x to the power 4. From here, what do I get my x to the power 12 to be equals to? This would become minus or plus 9 x to the power 4 plus 27 minus 9x to the power 4. This and this simply gets cancelled out. So what do I get? X to the power 12 is equals to 27. So this is one of the equations that I've found out. Now we all know that alpha beta are the roots of this equation. That means alpha beta would satisfy this equation. That means I can say alpha to the power 12 would also be equal to 27, or simply I can write it down as 3 to the power 3. And beta to the power 12 would also be equals to 3 to the power 3. So we've gotten our roots. Now we had to find out the value of alpha to the power 96. It can be written as alpha to the power 12 whole to the power 8. So this becomes 3 to the power 24 basically. This value would also be equals to beta to the power 96, 3 to the power 24. Now what was asked to us in the question? We had to find out alpha to the power 96, alpha to the power 12 minus 1 plus beta to the power 96 and beta to the power 12 minus 1. This was what we had to find out. So now I can simply replace these values. This would become 3 to the power 24. This would become 27 minus 1. This would become 26 plus 3 to the power 24. Here I would have again 26. So ultimately this becomes 52 into 3 to the power 24. And this is our answer. So this is how you generally find out the values when the powers have been given too much. What you do is you simply keep one of our unknown variables of 1 degree to the one side and the other ones to the other side, and then you start squaring or multiplying by x square or x to the power 4. Then at some point you will see that by replacing any one of the x's values, you are going to get all the other terms cancelled out, and once those terms are cancelled out, you would simply be able to find out your answer. So that is how you solve these types of questions. Now let's look at this question as well. What has been given to us? So what I'll do is I'll assume this entire equation that has been given to us to be x. Let's say this is x. And this goes up till infinity. Now, what is the one common thing that I can see? That after 3 plus 1 upon 4 plus, what I'm getting is I'm getting the same thing repeated again and again. And it goes up till infinity. So if I have, let's say, infinity minus 1, what is the value going to be? It is still going to be infinity, because infinity is a very large number. We do not know what is it. So can't I write this entire equation as 3 plus 1 by 4 plus x? Or simply, sorry, not here, upon 1 plus 3 plus x, because now each and every term is getting repeated again and again. Sorry, this 3 plus won't be here. This is just x, because after 1, now you can see that this entire portion here, this seems to be the value of x that we have just written down, right? So I can write it down as 3 plus 1 by 4 plus 1 by x. Now I can simply solve this equation and find out my value of x. So from here, what do we get? This would become x minus 3 is equals to, this would become x upon 4x plus 1. If I cross multiply this would become, let me take this to the other page. This would become 4x square minus 12x minus 3 plus x, and this is equals to x. So from here, x and x gets cancelled out, and we have left with this equation 4x square minus 12x minus 3 is equals to 0. Now I need to find out the value of x. This is a quadratic equation, so what used to be the solution of a quadratic equation? Minus b plus minus root under discriminant upon 2a. So minus b, this would become 12, plus minus root under b square minus 4ac, so this would become 4 plus, sorry, 4 4s are 16, 16 3s are 48 upon 2 4s are 8. So this transforms to 12 plus minus root under, this would become 2 here, 1 here, 9, 192 by 8. So from here, what do we get? If we take 3 inside common, this would become 64, and we know 64, it becomes, so this would become 12 plus minus 8 root 3 by 8. 8 and 8 can simply get cancelled out, and 8 can cancel this out 1.5 times. So this would become 1.5 plus minus root 3. This is our answer. So I hope you must have understood this thing. Whenever you have been given a number which is, let's say, going up till infinity, what you can do is you can assume the entire thing to be x, and then see from where the pattern is getting repeated. Once identify from which portion the pattern is getting repeated, you can also assume that portion to be x. From here, you could see that from here my pattern was getting repeated. So this portion was exactly what I assumed to be x. So this becomes x is equals to 3 plus 1 by 4 plus 1 by x. So that is how you solve such type of questions. Keep this question in mind. This is a very important question and a good question that was asked in 2021. So that was all about this chapter. As I mentioned, this is a very short chapter, the most easiest chapter and the most basic chapter that you could have seen in JEE Mains. More or less each and everything you have already covered in your school time. So there isn't much new things that you studied. The one important thing that you learned here was the graphical representation. You must understand how the graphs of quadratic equations look like and how they can be represented on our x and y plane. So based on that, you can solve your questions. Apart from that, that's all. Thank you.